In these questions, we're going to use graphs and we're going to work out slope charts from these graphs. So this example is a question from the 2023 exam, and the graph of f prime is given, and it asks, on what open intervals of f is it increasing? Okay, so to do that, we need to make a slope chart. And to make this slope chart, we want to know where the graph is increasing or f prime is positive. So we have f prime is positive here, 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 all the way through there, and where it's negative. So f prime is negative through here. So when I do my slope chart, my f prime from -2 to -1, we know that we have positive slope. Okay, at f of -1, we know we have 0. That's a horizontal tangent. And at f prime between -1 and +2, we know that is sloping down because the derivative y values are negative. And then between 2 and 8, actually we'll just do 2 and 6 to start. So 2 and 6, we know we have a 0 slope here. Okay, at that point we have a 0 slope, but we do know we're going to have a 0 slope at 2, and that becomes a horizontal tangent as well. We know it's positive between 2 and 6 here. That's all positive. We've got a horizontal tangent here, and then again it's positive on the other side, so this is what we would consider a slide through that point. Okay, so the intervals that it is increasing, we know that it's increasing from -2 to -1. We know it's increasing from 2 to 6 and from 6 to 8. Those are the intervals that's increasing. And just a reminder, we have to split it up at 6 because it's not increasing at that point. It's just going to be a horizontal tangent at that point. For part B, it says, on what intervals is the graph both increasing and concave up? So we've got the increasing part, so we just have to figure out concavity. So when we're talking about concavity, we're talking about where the derivative is sloping up or down, or the change of the derivative. The change of the derivative is the second derivative, and that indicates concavity. Okay, so where does it change concavity? Well, we have to look at where the graph is sloping down. Okay, so where the derivative is sloping down, we know that we have a negative concavity. So from -2 to 0, okay, that whole portion, we know it's sloping down, which means it's the second derivative negative, so it indicates a negative concavity. We know that the second derivative is undefined at 0 because it's a point. And then from 0 to 4, we know that it is sloping up, or the second derivative is positive. That means we have a positive concavity in there. Okay, all the way to 4. And again, there's no second derivative defined at 4 because of that kink in the graph. So anytime a graph changes direction, we have an inflection point. So again, we're going to slope down from here to here. Okay, this happens to be that point there, and I'm going to do it in a different color. That point there does happen to be a 0 concavity point. So at 6, we know the second derivative is equal to 0, and between 4 and 6, we know it is sloping down, so it's negative concavity. And then from 6 to 8, it's sloping up, so we know that The second change is positive. It's positive concavity there all the way to 8. Okay, so then we need to determine when is the graph both sloping up and positive concavity. Well, the graph is sloping up from 2 to 6, but only positive concavity from 0 to 4 or 2 to 4. So 2 to 4 is going to indicate that region. Okay, so I'm just going to mark that off. There's 2 from above, and there's 4 from below. Okay, so the region that is both concave up, increasing concave up, one of the regions is going to be from 2 to 4. And where else is it sloping up? Well, between 6 and 8, it is both concave up and sloping up. So I'm going to just highlight that again. So between 6 and 8, sloping up, 6 and 8, concave up. So there's another region that we can choose. So between 6 and 8, in that interval, it is both concave up and increasing.